Good evening everyone, welcome to Gradeup, India's largest e-learning platform. So today's session we are going to discuss about the irrigation techniques, the left out topics that we were discussing yesterday. So this is a startup series for GATE 2021, alright, and this is the second subject of this particular series, which is your startup series. So is already completed and now I'm here in front of you with irrigation engineering, alright. One session is already done yesterday. Hi Nandini, everyone, good evening. I hope everyone is doing great. Okay, so we'll just begin session without wasting any time. All right. Hi Shruti. Hi Askifo, how are you? All right, so what I'm trying to do here is I'm just trying to give you a proper visualization of things that are happening around you, which are related to irrigation techniques, okay, with the help of a good representation, you can say. All right, so we'll just begin the session of irrigation techniques. Till now we have discussed certain type of irrigation techniques, and now we will see all the left out irrigation technique plus the quality of water, which is important for any kind of crop. As the quality of water is important for us, similarly it is important for the crops as well. It definitely going to affect the yield of that particular crop. So let's begin the session with a very good and short introduction of mine. All right, so this is me. I am M.Tech from IIT Roorkee and I have qualified GATE 17, 18 and 19. These are my area of expertise and this is the subject, these are the subject which I'm going to teach you. All right, so let's just begin it without any further. So next technique that we have to discuss is furrow irrigation. What is furrow irrigation? So this is how it looks completely. As you can see here, all the crops will be there on a high leaves, okay, on the high leaves, and the water is going to flow through these channels, sorry, line thoda sa teda ho gaya, these channels. All right, so what we are doing here is we are having this type of technique. All right, what it is doing here, see the amount of water, the surface area for which this water is explored, all right, for which it is exposed to the atmosphere is less. That's why the evaporation will also be decreasing. All right, next thing is furrow magnitude vary from 8 to 30 centimeter deep. What is furrow? These are the furrows. So we are talking about, this is deep, we are talking about, sorry, so we are talking about the magnitude of their heights, all right, of these furrows, and then length of these furrows can reach up to 400 meter. All right, the length could reach up to 400 meter. Which length I'm talking about? The length, this length, it could reach up to 400 meter. All right, so these are certain points which we have to discuss regarding furrow irrigation. Most of the places, most of the irrigation fields are using this type of irrigation technique. Practically you must have seen it somewhere because this is very common. All right, let's see what we have next. Sprinkler irrigation. So sprinkler irrigation, it looks something like this. It has a complete jungle, or it has a complete connection of pipes. Okay, so what we are doing here, if you look closely, what we are doing here is we are trying to get an artificial rain. We are producing our own rain, okay, because that's the best thing that we can do with the irrigation, by providing the artificial rain. So this is only possible if we are going to use the sprinkler irrigation. All right, hi, hello Samita. Perfect. Till now everything is set. Good. Next thing is, what are the advantages? Why we are choosing sprinkler irrigation over other techniques? There should be certain advantages. So let's talk about those advantages. Okay, फायदा नहीं होगा तो उसको यूज ही नहीं करेंगे, क्यों यूज करें? All right, so here the thing is uniform distribution is achieved. you are able to distribute the water uniformly, because this is the one of the most important factor when we are doing the irrigation. All right, next is no runoff from the field. So we are providing water in a spray form. All right, we are providing water in spray form. So what is happening here is, as you can see, there is no concept of stagnant water. Water will not be getting collected, and as the water cannot be collected, similarly it won't run off, it won't flow on the field. So that's why we can say no runoff on the field, no seepage losses. We are providing water in an optimum, very optimum manner. So definitely there will be no seepage. There will be no seepage. So if there is no seepage, then no water is going to what we call it, meet the underground water. And as soon as it won't go underground, it won't take the pesticide and fertilizers with this, and it won't pollute the groundwater. It won't pollute the groundwater. All right, next is increment of this particular area, the irrigation area, you can say up to 16%, increment of up to 16% of the cropped area. Why? Because we are not wasting our land. We are not wasting our land for these channels which are there. We are not wasting the area here. All right, perfect. Okay, these are furrows. All right, next is some more things that you have to remember when we can use the sprinkler irrigation. Suppose if the land topography is irregular. So since the land topography is irregular, so what will happen? There will be unused amount of water also. Suppose we have this type of topography of our irrigation field. All right, and we have our crop here, here. All right, and when I am applying water, the water will be such that it will look like this. All right, it will look like this. So due to this irregularity, what is happening? What is happening here? See, this water is nothing but wastage. This water which is getting collected in these ditches is nothing but wastewater. We are not using this water. The crops are not using this water. All right, so that's why we can use these type of technique when the topography is irregular. All right, next is whenever the water table is high. So if the water table is high and we are providing this type of system, what will happen? The water table is already high, so the water level will rise eventually. Which problem will occur with irrigation? There are basically two very important disadvantages. One was the seepage loss, second was the water logging. So if the water table is already high and again I'm going to draw some water, again I'm going to apply some water in a high quantity, what will happen? Water logging will be there. Water logging will be there. What is water table? Okay, somebody asked what is water table. Suppose this is your land, this is your ground surface, all right, and there is this underground water here. So this is your water table. Okay, this is water table. All right, define water logging. I think you weren't there in yesterday's session. We discussed the water logging in the previous session, but I'll give you a quick revision kind of thing. So water logging is nothing when we are applying water on a field. Due to this type of irregularity, water will be at a place, it will be stagnant, it won't move. Okay, and as the water is stagnant in a very complete big area, what is going to happen? There will be the production of very harmful microorganisms. okay, as well as mosquitoes will also be produced from that stagnant water. All right, so that's why waterlogging is a real big issue, and those microorganisms will cause damage to all the crops, as well as they will give you a very foul smell. All right, so that's why we have to avoid the waterlogging problem. Okay, and by providing sprinkler irrigation, we can easily do that, because there will be no collection of water at a particular irrigation field area. Perfect. Next is, we can also uniformly apply the fertilizers. We can also apply the fertilizers uniformly. Seepage means, okay, so clearly you people were not there in yesterday's session. No problem, I'll again give you quick revision kind of thing. So suppose I have this irrigation field, all right, and this is my groundwater table. Okay, underground water is here. So now as soon as I'm going to apply the irrigation or irrigation water here on the field, so it will come here, water will come here. Now eventually what will happen? It will start seeping inside, it will start going downwards. The excess water, one amount of water will be that which the crop is going to use for its growth, but there also some amount will be left. So if the left amount will go downwards due to the gravitational action, what will happen? Eventually it will meet the water table. Is there any problem with this? Yes. Why? Because this water is not a normal water. This water comprises of pesticide, fertilizers, and so many things which can pollute any kind of water. So these fertilizers will also flow through these pores, you can say, and they will join the water table. Now they have polluted the water table, underground water. So as soon as we are going to draw water out of this, which is your underground source, what you will get? You will get a polluted water. You will get a water which is mixed with the fertilizers and pesticide which we use to kill the pest. This is why seepage is not good for us. Perfect. I hope I'm clear with this now. Is it clear, Pushpraj and Hari? Runoff is nothing but behna. Okay, suppose this is your land. This is your land again, and water is coming through rain. Just take example of rain. The water is coming, all right, and it is accumulating here. It is accumulating here. So again there will be some amount of water which will be consumed by the crop, but there will be some extra amount of water also. What will happen? It will just flow through this surface and it will go eventually somewhere else. So this flowing is known as runoff. Runoff. Water is running off. All right. So this is what we call runoff. So these type of issues are not there in sprinkler irrigation. Next thing I was telling you was the uniform application of what? Uniform application of fertilizers. What is the difference between seepage and permeability? Seepage is the ability, you can say, seepage is the water which is flowing through the pores. It is seeping down through the gravitational action. Permeability is the ability of a soil sample which allows the passing of water through pores. So you can say seepage is department of water and permeability is department of soil. All right, this is the basic difference I'm telling you. Okay, next is, there are certain limitations. Now we have to talk about limitations also, because it is not possible that the thing has only and only advantages. Okay, so let's see what are the disadvantages or limitations. Let's not say they are disadvantage, we'll say limitations. Okay, hi Aman, how are you? All right, so one of the biggest limitation is high wind velocity. when there will be a high wind velocity, the wind which have very high velocity, what will happen? They will just distract the flow of this spray. They will just distract the flow of this spray. And one of the best thing about sprinkler irrigation was the uniformity, in the manner in which the uniform distribution was taking place. But since it is now distracted, so this best thing is now not achieved. Okay, this is not achieved. All right, so this is the one of the biggest limitation. All right. Okay, then we need a very large electrical supply for this, because what we are doing with the help of pump and all, we are bringing this water up and we are converting this water into spray through spray nozzles. Okay, so what is happening here? We are going to need a very large electrical power. Second limitation. Third limitation is we are going to face one more issue, which is constant supply of water. We need a constant supply of water till we have provided water to whole irrigation field. Okay, so these are these type of limitation with this. All right, and we cannot use this type of method for the irrigation for the crops which need larger depth of water. Okay, which needs larger depth of water. Suppose your rice. So rice, in the beginning you have to sow them, the seed you have to sow them, and you have to completely keep them in water, and that is known as your paddy field. So this type of irrigation cannot be used for paddy fields or the crop which requires very high amount of water. All right, so this is regarding your sprinkler irrigation. Let's see what we have next. Drip irrigation. All right, very high, you can say technical or high-tech technique. This is drip irrigation, very high. This also known as trickle irrigation. This irrigation technique is also known as trickle irrigation. कोई भी डाउट हो आप पूछेंगे तुरंत. ट्रिकल इरिगेशन, कोई भी डाउट हो स्प्रिंकलर को लेके प्लीज आस्क. Yes, I have just started drip irrigation, so give me time. I'm asking about sprinkler. If you have any doubt regarding sprinkler irrigation, please ask. I'll just again give you an overview. This is how it looks. All right, these are the advantages. Limitation are it won't work when the wind velocity is very high. It won't work. It requires very high amount of electricity. It required constant supply of water. Also, it cannot be used for the crops which require high amount of water, such as rice in paddy fields. Okay, now let's talk about drip irrigation. This is the very best method for the places where we have scarcity of water. Okay, where we have scarcity of water. So scarcity means lack of water. All right, so wherever we are going to have lack of water, we are going to use this type of method. As you can see, there are certain pipes you can see here. All right, and we are going to provide water directly to the root zone. Directly to the root zone we are providing. So what it is saving for us? It is saving the evaporation losses for us, the percolation losses for us. The seepage will not happen. The waterlogging will not happen. So these are the things that you are going to get if you are going to use drip irrigation. All right, no evaporation, no percolation problems. Water is applied directly to the roots. Okay, directly to the roots. So this is one of the best thing about it. All right, so this is your drip irrigation, very high-tech technology regarding irrigation technology. Okay, in the beginning only and yesterday also I have discussed this thing. Quality of water is not only important for human beings but also for the growth of crops. It is really important that we use good quality of water for irrigation purpose. All right, So quality of water could be, see, there is one type of water which is known as unsatisfactory water. What is unsatisfactory water? See, some type of which is more costly. Sir, sprinkler is more costly because it needs continuous supply of electricity as well with the continuous supply of water. Okay, with the, all right. What is percolation? Percolation is nothing but seepage only, as it seeps, percolating, seeping, similar. All right. So what is happening? Quality में क्या होता है? See, unsatisfactory water. Unsatisfactory water is which is not satisfactory for the growth of my crop. So that water will be known as unsatisfactory water. Okay. Next is what make the water unsatisfactory for my crop? There should be certain reasons. So one of the reason is the sediment concentration. All right. Next is your concentration of soluble salts concentration and the sedimentation concentration. Next is concentration of toxic elements. Very important. Okay. Toxic. All right. The sedimentation, concentration of toxic sedimentation elements. Next is bacterial contamination. Again, it's a very big issue, which is your bacterial contamination. If it will be there, then there is no use of applying pesticide or fertilizer. Okay, because the water that you are supplying, that is only polluted. Then what you will do by applying fertilizers or pesticides? All right. So these are certain problems with this. Okay, so as we all know, the salinity is a big problem. So we have a general formula for calculating the salinity here. CS is nothing but salinity concentration of soil solution. All right, you can just directly go through this formula. Direct formula is there. I'm just going to tell you the elements, what does they mean. So here Q is the quantity of applied water. Q is the quantity of applied water. All right. Next is your Cu is the consumptive use. PEF is the useful rainfall. Rainfall will be there, and it is not important that the crop is going to utilize all the water which is coming from rain. There will be some water which will run off. There will be some water which will go inside the earth's surface and it will join the water table. But there will be amount of water which the crop will utilize, and that amount of water is known as your useful rainfall water, which is P effective. That's why we are calling it P effective. All right. And C is the concentration of salt. This C is the concentration of salt. Okay. Let's see what we have next. SAR. What is SAR? Let's see. So any water, polluted water, it could have calcium, magnesium and sodium, very small amount of sodium in its composition. Okay, it can constitute these type of things which are harmful for our particular soil. What is going to happen if we are using this type of, water which has sodium ions more than the satisfactory limit? What is going to happen? So if suppose the percent sodium is less than 5%, then it is good. Perfect, no problem. If sodium ions percentage is less than 5%, then no problem. But if it is more than 5%, then we have problem. Why? If the soil is wet, when the soil is wet, the irrigation field is wet, at that time if the sodium ions are more than 5% or it is a highly sodium water we are using on the soil, so what will happen at that time? In wet condition, the soil will be very sticky. Very sticky. Okay, and it will be very plastic. Secondly, if the soil is dry, if the irrigation field is dry, so what will happen? It will convert into crest. Okay, it will convert into crest and it won't allow water to go inside the root zones. So very harmful for our crops. All right. Sodium ion present in soil generally measured by this factor SAR, and you can get the value of SAR with the help of this formula. You have to write the value of Na positive, will be given in the question, calcium and magnesium, divide by 2 under root, and you are going to get the right answer. Crest means I hope you understand Hindi. I can explain you better in Hindi. Crest means सूख जाना. So सूख जाता है तो पपड़ी बन जाती है. Alright, and the ground, the particular area will become very hard. Okay, it will become very hard that it will be very difficult for the water to go inside the soil. Alright, perfect. Alright, done. So this is your concentration of soil, or you can say salinity, and this is your SAR. What will happen if soil is wet? What will happen if soil is dry? What is SAR? SAR is a factor in which we are going to calculate or measure the amount of sodium in the soil. In the soil, the full form of SAR is sodium absorption ratio. Sodium adsorption ratio, not absorption. Adsorption. Adsorption is the outer phenomena. All right, so this is how you can get the values, and we have also differentiated the soil into various categories depending on the value of SARs. So this can come directly in the examination. S1, if the SAR value is 0 to 10, then it is a low sodium water. It is a low sodium water. If it is 10 to 18, then it is a medium sodium water, also known as S2. And if it is 18 to 26, it is S3 or high sodium water. But if it is more than that, then it is very high sodium water. Okay, very high sodium water. What is the difference between absorption and adsorption? Okay, so suppose we have a particle here, solid particle. All right, now we will see adsorption and absorption. We will see adsorption and absorption. Absorption and adsorption. Perfect. We have same two particles here. Two particles. All right. So what happens in case of absorption? What will happen? When you are going to apply water to this particle, it will absorb. It will absorb. What is absorption? The water will go inside the body. Water will go inside the body. But when you are going to apply water to this particular particle, what will happen? The water will accumulate here. It is not going inside. All right. So in this manner, practically you can see what is absorption and what is adsorption. All right. Perfect. सही है, set है, all set. Are we good? All right. So this completes your first chapter of irrigation engineering, which is your irrigation technique and the quality of water that we are going to supply. Okay. Perfect. All right. So this is it. I think this is the whole information for the first chapter. Yes, irrigation engineering first chapter is done for you, and I have not, I think no topic is left. All the topics have been discussed precisely with the proper visualizations. Okay, this is how they looks in real life, in real irrigation field. All right, so I hope I was able to communicate you in a better manner. All right, and first chapter is completed, and I'm going to come back with next chapter with a very precise and a very what you can call it, concise information of those particular chapters. All right, and we'll solve some questions also. No question was there, actually only theory questions are there regarding this chapter, so that's why I have not chosen any question for these type of sessions. Not required actually. If you will go, you can now go and solve the questions of this chapter. You will be able to solve the questions. No problem will come in that particular chapter for you. Okay, so this was first chapter of irrigation. We'll see the next chapter on Monday, same time. All right. As you all know, this course is going on. This is a free, actually paid course, but trial period is going on. Demo classes are going on. It is a live course. It is a 1 year complete course of GATE and ESE, both technical and non-technical syllabus as well. All right. Which time? See, these lectures of GATE 2021 on YouTube will always be at 9:30. Will always be at 9:30. We have one more series, which is your, what we call it, revision series, and it will always there at 5:30 p.m. okay, so if you have joined late, you can watch this video later on, and you can, if you have any doubt, you can post your doubt in the comment section. Okay, all the what you can call it, doubts related the price and discount offer and all the sale offer, you can ask in the doubt section of Gradeup app. Okay, our team will be contacting you, and they are the best people to talk regarding the price. I can only give you the trust that we are going to give you the best knowledge, we are going to give you the best environment. The best part about this course is, for me personally, I can say that it is a live course. It is not recorded class. You can ask doubts similarly that you are asking right now also. You can ask doubt at that time. Okay, so this is one of the best thing about it. Rest, you can go through the Gradeup app. There you will be able to find this course, and you can go through the videos. They are free right now. If you want, you can watch the videos. Currently no money will be needed for watching those videos. You can just go and check this. Green Card, it is a scheme of Gradeup where you can get the access to all the mock tests which are there on the app for whole 1 year. All the tests related to not only GATE or ESE. Any examination is coming, then we are going to launch the test. You will be able to get the access to that test. If you are going to buy yearly card, you will be getting it for whole 1 year. And if you are going to get the monthly card, then you will be able to access all the mock tests for whole 1 month. All right, I'm saying this again. Gradeup app, as you all know, so much of free content. Please come there and enjoy the free content. Only the course is paid, nothing else. Everything is free. Notifications, you can get the job notifications. You can get all the previous year question papers on this app. All right, also you can follow me on this app. My name is Joshit Singh. If you want, you can follow me at this app, and you can ask your doubts in the doubt section of this app. All right, your doubt will be resolved. Perfect. So I think it's the time when we have to say goodbye to each other. My time is over because chapter is over. I hope I'm going to see you on Monday with full energy, with full enthusiasm, and we are going to make these lectures, because these timings are very boring actually, but I'm going to make them very interesting for you. You won't feel bored during our lecture, during my lecture especially. Okay, so thank you so much. Thank you for being here. Thank you for your patience. Good night everyone. Take care. Prep smart, score better. Go Gradeup. If you feel that video has helped you in any manner, you can just like the video and share it with your friends. Thank you so much. Good night.